So I proved in previous video that Laplace transform of square root of t is equal to pi under root divided by 2 into s power 3 divided by 2. It is the Laplace transform, and I concluded that gamma of 1 over 2 is equal to pi under the root. So first I'll prove that how gamma of 1 over 2 is equal to 5 under the root. So we know that the beta function representation, that it is equation B. So integral from 0 to pi by 2 sine of p theta cos of q theta d theta, it is equal to beta of p plus 1 divided by 2 q plus 1 divided by 2 whole divided by 2. So if p is equal to 0 and q is equal to 0, so it will be integral from 0 to pi by 2 sine power 0 equal to 1 cos power 0 equal to 1. So 1 multiply with 1, it is 1. So it will be d theta, it is equal to beta of 1 over 2 per p equal to 0, q equal to, it is 1 over 2 whole divided by 2. So we know that beta of mn is equal to gamma of n divided by gamma of m plus n. So integral from 0 to pi by 2 d theta, it is equal to gamma of 1 over 2 gamma of 1 over 2 divided by gamma of 1 over 2 plus 1 over 2, it is 1 and whole divided by 2. So integral from 0 to pi by 2, it is theta with the upper and lower interval 0 to pi by 2 with the gamma of 1 over 2 gamma of 1 over 2, it is gamma of 1 over 2 whole square with whole divided by 2, and it is of 2 and of pi by 2 minus 0. So gamma of 1 over 2 whole square is equal to 2 pi by 2 minus 0. So 2 cancel out with this 2, and pi is equal to 1 over 2 gamma of 1 over 2 whole square. So taking square root on both sides, so gamma of 1 over 2 is equal to pi under the root. So in this way gamma of 1 over 2 is equal to pi under the root. Now I know that Laplace transform of t under the root, it is equal to pi under root divided by 2 into s power 3 divided by 2. It is the proof. So if we find the Laplace transform of 1 over under root of t, so Laplace transform of 1 over under root of t is equal to integral from 0 to infinity Laplace transform of f of t equal to 1 over integral from 0 to infinity t power minus 1 over 2 e power minus st dt. We will put it in, we will compare it with gamma function. So it is equation C. Now the gamma representation is that integral from 0 to infinity t power n minus 1 e power minus at dt. It is a gamma of n divided by a power n. So if I compare equation C and D, so it will be gamma of n, so it will be gamma of 1 over 2 divided by a power n. So a is equal to s, so s power 1 over 2. So gamma of 1 over 2, I prove that it is pi under the root, so pi under the root divided by s power 1 over 2. So Laplace transform of 1 over under root of t is equal to pi under the root divided by s power 1 over 2. Now the property of Laplace transform is that we will derive it easily. I can easily write it. If I multiply t on both sides, then it will be t. So Laplace transform, it is the property of Laplace on the t f of t, it is equal to minus d by ds of f of s. It is the property of Laplace transform. So if I multiply t, then Laplace transform of t divided by under root of t is equal to Laplace transform of t. I can write it t under root, so it will cancel out. So Laplace transform of t, so t is equal to, I will derive it t by ds pi under the root divided by s power 1 over 2. So it will be minus 1 over 2 s power minus 3 divided by 2 with pi under the root. So it will be minus with this minus it is plus, so it will be pi under the root divided by 2 s power 3 divided by 2. So Laplace transform of t under the root is equal to pi under root 2 into s power 3 by 2. So in this way this Laplace transform is solved without the help of beta function in this way.